Hi to all. Today's topic is most important for the CBSE board exam and other competitive exams. And the today topic is current density. What is current density? Current density is denoted with J. It is a vector. We know already current. Now what is current density? Right? The current density is the current flows per unit area. Current flows per unit area of cross section. Current flows per unit area of cross section. Current flows per unit area. Current flows per unit area of cross section. Okay, that is called as current density, or the current per unit area is called as current density, provided current is perpendicular to the surface or the area of cross section. Current is perpendicular to the area of cross section. This is the condition. I will explain everything. Okay. What is current density? Current flows per unit area is called as current density. For example, this is a wire, right? This is a wire. Now its cross section is this one. This is the cross section. The cross section is in the circle shape, right? And now the current, for example, the current flows this side. This is the direction of the current. This is the direction of the current. And now this is the surface area. Okay, this is the surface area. The surface area is A. Now what current is perpendicular to surface area, right? Current is perpendicular to surface area. Area vector direction, what is the direction of area vector? Area vector already we know that area vector is perpendicular to surface. In Gauss law applications we discussed the area vector in the electric flux first chapter. Area vector is a vector, right? It is perpendicular to the surface. For example, this is our surface. Okay, my hand is the surface, and now this is our sketch is the area vector for the surface, right? Area vector means what? It's a vector. It is perpendicular to surface, and its magnitude gives the surface area, and its direction is perpendicular to surface. That means now the surface area perpendicular to current, provided current is perpendicular to area of cross section, right? And this is area of cross section, and this is current. Current and area of cross section are perpendicular. Okay, that means area vector is right side will be there, right? The current and area vector are along same direction, and at that moment the current density formula is current is equal to current density J. Current density denoted with J. It is the formula current per unit area. Current by area. Its formula is J is equal to I by capital A. This is the formula for current density. Current density is the current per unit area, but this is applicable when the direction of the current, is parallel to area vector. Direction of the current is parallel to area vector. Current is right side, area vector is also right side. At that moment, the current density formula is current by area, or current perpendicular to surface area. Otherwise, we can tell like this: the current perpendicular to surface area. Now let us see, if the current is not perpendicular, then at that moment how we will write the formula. And the current density, note that, right? Current density is a vector. Current density is nothing but current by area, current by surface area. Current per unit area of cross section is called as current density, and current density is a vector. Current density is a vector, and its direction, or it is along the direction of, it is along the direction of along the direction of current, along the direction of current or electric field, electric field. This is current density. Current density is a vector. It is along the direction of the current or electric field. Current density is a vector. What is its direction? Current density is along the direction of current. That means the current density also right side. Current is right side. Then the current density is also right side. Right? And now we are telling that the current density is the current per unit area. Current per unit area, simply current by area, current per unit area. Then what is its unit? SI unit. It is a current per unit area. That's well, current is unit is ampere by area. Area is meter square. Current per unit area. And now if current is not perpendicular, okay, if current is not perpendicular to the surface area, then how to write the current density formula? For example, we are taking, this is a wire, okay, it has the area of cross section. I am taking the area of cross section like this. This is the area of cross section. Now at this moment, area vector is what? For example, the current and current density is along this direction. This is the direction of the current, or this is the direction of the current density. Current or current density is along this direction. Okay. And now area vector is perpendicular to surface. This side area vector will be there. Area is like this there. Perpendicular to area means it will be along this direction. This is the area vector, right? Now there is some angle between the area vector and current density, right? That is theta. In this case, current area vector is right side, perpendicular to surface. This is the surface, perpendicular to surface. Area vector is right side, and current is also right side. Then there is no angle between them. But here there is some angle. At that moment, we write the current density formula as J is equal to I by A cos theta. We write I by A cos theta. We have to write. We have to take the component of area vector along the direction of current density. This is the formula. Okay, you have to remember, it is a basic formula. And now we will take I is equal from this J A cos theta. We write, and here we write this is in vector form. I is equal to J bar dot A bar. Why? How we are writing this one? Right? This we are writing from A bar dot B bar formula is AB cos theta. This is the dot product formula. From that we write J A cos theta is J bar dot A bar. What is J bar in this? J bar is the current density. What is A bar? A bar is the area vector. Area vector. Okay? A bar is the area vector. Area vector means magnitude equal to surface area. Magnitude is equal to surface area. Magnitude is equal to surface area, and direction is perpendicular to surface. Perpendicular to surface. This is about area vector. Okay, current density is a vector, but the current I is a scalar. You must remember, current is a scalar. This is about current density. Current density is nothing but current by area. Current by area. If current and area vector are along same direction, we can write the current density formula current by area. If they are at certain angle, right? What is theta in this? Theta we can also write theta. Theta is, okay, angle between J bar and A bar, right? J bar and A bar. This is about current density. And now I am going to tell the next continuation and relation between the current density and the conductivity and electric field. That formula I am going to derive. Okay, it is important. Can you rub this? Take the screenshot and note it. Next topic is relation between J, sigma and E. relation between J, comma sigma and E. What is the relation that I am going to derive? And for that, let us take one conductor, right? We will take one conductor, and this conductor has the length L. This conductor has length L. L is the length of conductor. Length of conductor. And for example, this side we will connect to positive, and this side we will connect to negative. At that moment, electric field will be produced, right? What is the direction of the electric field? From positive to negative. Positive to negative. This side we will connect to the positive terminal of battery. This side we will connect to the negative terminal of battery, right? And E is the electric field intensity. Electric field intensity. And V is considered as potential difference across wire of length L. Okay, and rho is considered as resistivity of wire. Rho is the resistivity, sigma is conductivity of wire. Okay, conductivity of wire, and E is the electric field. Okay, J is the current density. These are the terms that we are using in this. Now let us see. I am going to derive the formula, and when we connect this end to positive terminal and this end to negative terminal, there exists some potential difference across the wire, right? What is the formula for the potential difference? Potential difference across the wire. Potential difference across wire. What is that? V. V is equal to formula. We have one formula, right? Potential difference, electric field formula. We are applying the electric field at here, right? Or the potential difference. We have formula. Potential difference formula is magnitude of potential difference, E bar dot dr bar. E bar dot dr bar. Okay, and this formula we can also write. Potential difference we will take as V. Okay, E is the electric field. Displacement we will take as electric field across the conductor I want. Electric field is E, and potential difference across the wire is V. Potential difference is equal to electric field into distance. Here the distance is L. V is equal to EL we write from this formula, and V is equal to EL we write. This we will take as equation 1. Okay, and next I want the potential difference formula from Ohm's law, right? Potential difference across wire. Okay, right. What is the formula according to Ohm's law? According to Ohm's law, we write V is equal to IR. V is equal to IR, where R is, we write R. R formula is the resistance. Right? Resistance we write as rho L by A. We write. Okay. Then we write rho L by A. We write. This is equation 2. Okay. From equation 1 and 2, the both are for what? Potential difference. From equation 1 and equation 2, right? Left sides are equal. Then the right sides also we can equate. Then EL is equal, we write as I rho L by A. This L will cancel. Then we will get E is equal to I rho by A, right? E is equal to I rho by A. But in this case, what is I by A? I by A is already, you know, that current by area is the current density, right? Current by area is current density. Then we write E is equal to I by A, current by area is current density, we write J into rho, we write. Okay, E is equal to J rho, we write. Or we can also write as J is equal from this, okay, from this current density J is equal to, we write, how we are writing this equation? Because we know already that is current density formula is current by area. And now here I will write the current density formula. J is equal to E by rho. Right? J is equal to E by rho. J is equal to E by rho. 1 by rho is the resistivity. Right? 1 by resistivity is the conductivity. Right? Conductivity is sigma. Conductivity is sigma. Its formula is 1 by rho. That means here this we write as 1 by rho into E. Right? But rho is 1 by rho is what? 1 by rho is sigma. It is not P. Remember that. Okay? J is equal to sigma E. This is the relation between J and sigma and E. What is J? Current density. What is sigma? Conductivity. What is E? Electric field. The relation between J, sigma and E is what? J is equal to sigma E. And the next, let us go for the next topic. The next topic is drift velocity. Okay, our topic is drift velocity. Now, how to derive the formula for the drift velocity? Let us start. Okay, today now I am going to continue the topic. That is, next topic is drift velocity. Right? What is drift velocity? And the drift velocity means, the definition of drift velocity is the average velocity acquired by electron under the external force. Average velocity acquired by the electron under the external electric field is called as drift velocity. What is average velocity acquired by the electron under the electric field? You know, let us take, this is a conductor. I will explain. This is a conductor. For this I am applying the electric field. How you will apply the electric field? This V is connected to the negative terminal of battery and this end is connected to the positive terminal of battery. At that moment this negative repels the electrons and this positive attracts the electrons. That's why the electrons in the conductor moves from negative to positive. Electrons goes to right side. That means now different electrons will go in with the different velocities. For example, this electron has the velocity v1, this electron has velocity v2, this electron has velocity v3 and this electron has velocity vn. Okay, and different electrons have the different velocities under the electric field. Right? Now their average velocity is called as drift velocity. Right? Why they are moving? Because of we are connecting this conductor to a battery. That means we are providing the electric field. Under the electric field, force will act. We know that force formula, force on a charge, electric field formula, force by charge, force formula, electric field into charge. Then under the electric field, force will act, F equal to EQ. Force will act on the charge. Due to that force, electrons will move. Right? Then electrons moves opposite to the direction of electric field. Electric field is from positive to negative, left side. This is the direction of electric field. But electrons goes right side. That means electrons moves opposite to the direction of electric field. In this moment, the electrons are acquiring some velocity and they are moving and their average velocity is called as drift velocity. Average velocity acquired by the electron under the external electric field is called as drift velocity. And now the next topic is relaxation time. What is relaxation time? Relaxation time is the time interval between successive collisions of electrons with the positive ions is called as relaxation time. Okay, what is this? I will explain. For example, we have a conductor. And now this is a conductor. And in this conductor there are free electrons are there. That free electrons are moving. These free electrons are moving. For example, here the free electrons are there means in the conductor positive ions also there. Actually free electron from where it will generate? For example, this is an atom, sodium atom, okay, or magnesium atom or copper atom. Okay, copper atom. From this, if free one electron is removed, at that moment this will become positive ion. Right? That means one free electron is there means along with that one positive ions also there. Right? And now when this electron is moving through the conductor, at that moment it will collide with the ions. And for example, here this electron is collide with the one ion. After that it is going this direction. Okay, this direction it is going. And from here to here the electron traveled. For example, this is the electron and here the electron collide with the positive ion. After that, this electron is started and moving like this after collision, and after coming to this point, again this electron is collided with the another ion, right? What happened in between these two positions? In between these two positions, electron traveled without any collision. Electron is collided with one positive ion at here, and the next electron is moving like this, and after that, after coming to this point, electron is again collided with another positive ion. Now the direction is changed. For example, the electron is going this side. Again here it is collided with some other ion. That means in between these two positions, here electron collided with one ion, next collision occurred at here. That means again the electron is collided with the positive ion, and next collision is occurred at here. That means again the electron is going freely from here to here. After that, electron is colliding with some other positive ion. That means from here to here, right? In between these two positions, this is one collision position, this is another collision position. Between these two positions, electron traveled through the conductor without any collision. That means now the electron traveled relaxedly. Now the time in which the electron traveled freely without any collision, that is called as relaxation time. From here to here, the electron traveled without any collision. Here collision is occurred and here collision is occurred. That means the time interval between successive collisions of electrons, with the positive ions is called as what? Relaxation time. Here one collision is occurred, here one collision is occurred. In between these two collisions, electron travel freely without any collision. The time interval between successive collisions is called as relaxation time. That is the relaxation time. Okay, and now next, relaxation time. In the relaxation time, it is freely traveling without any collision. That's why what happens when it is travel freely without any collision, at that moment it will accelerate under the electric field it is moving. In relaxation time, electron can accelerate under the electric field. Why it will accelerate? Because on electron, electric force will act because it is in electric field. In electric field, electric force will act. When force acts, then acceleration will be there according to Newton's second law. F equal to ma, a equal to f by m. And F is the electric force formula is eq by m. But q is the electron charge, that is minus e. Then we write minus e by m. E is the electric field intensity. Small e, capital E is the electric field intensity. Small e is the electron charge. M is the mass of electron. This is the acceleration. Acceleration negative means acceleration of electron is opposite to the direction of electric field. Okay, and now I am going to derive the one relation, that is the relation between the drift velocity and relaxation time. Here what is drift velocity we discussed. Here we discussed what is relaxation time. Now what is the relation between these two, that I am going to explain. You have to listen very carefully. This is very important topic, right? And whatever that we are discussing today, and that is very important for the board exam, right? And very important. And let us see how to derive this. For that, let us take this is a conductor. This is a conductor. And now one side I am connecting to the negative terminal of battery, and other side I am connecting to the positive terminal of battery. At the moment, the length of the wire is considered as L, and the electric field is from positive to negative. That means this side. And now electrons in the conductor moves from negative to positive. We know that electrons moves from negative to positive, like this electrons will move. And now when electric field is applied, some current will also flows. The current direction is from positive to negative, and electrons moves from negative to positive. Okay, and now this is the direction of the electric field. We will write it here. The electric field is left side. Now what is VD at here? Drift velocity. Relaxation time, drift velocity. In that we have to derive the relation between these two. For that, first we can consider initial velocity of electron. I will take as 0. Initially there is no velocity. Okay, and in the acceleration of electron. Now electron is accelerating under the electric field. Acceleration of electron under electric field, right? Under electric field. What is the acceleration? Do you know already? Acceleration is force by mass, but the force formula is EQ by m, but q is minus e. Okay, this is acceleration of electron. Electron is accelerating because speed is increasing. Why speed is increasing? Force is acting. Why force is acting? Because this conductor is in electric field. Electric field, electric force will act. Then here minus indicates, negative sign indicates electron accelerates opposite to the direction of electric field. Negative sign indicates what it indicates? Negative sign indicates electron accelerates opposite to the direction of electric field. Okay, right. And now acceleration we got it here, and now after some time it acquires some velocity, right? And in relaxation time, right? In relaxation time, the electron will accelerate. It will travel without any collision. When it will travel without collision, what happens if the collision occurs? Velocity changes, direction changes, but in relaxation time no collision. That means the time is capital time t is equal to tau, that is relaxation time. Velocity acquired by electron, right? What is the velocity acquired by electron? Tell me, what is the velocity acquired by the electron? Right, velocity acquired by electron is the drift velocity, right? The final velocity is equal to drift velocity. Now let us start. We know the first equation of motion, right? Do you know first equation of motion? What is the first equation of motion? There are three kinematic equations are there. V is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to as, right? In that the first equation of motion is v is equal to u plus at, that we will use now. Okay, and what are the data that you know it here? Actually what we are going to find out? We are going to derive the relation between the drift velocity and relaxation time. Okay, right. Now let us see here, and it was very simple to derive. And now here what data we gave? We got initial velocity 0, acceleration is minus e by m, and the time is tau, relaxation time, and the velocity acquired is drift velocity. Now v u at relation we have. Then according to equation of motion, v is equal to, we have u plus at, and v is vd, and u is 0 plus a is minus e by m into t is tau. Then here the drift velocity formula we will get is minus e by m into tau. This is the formula for the drift velocity. It is the relation between the drift velocity and relaxation time. Okay, drift velocity and relaxation time. From this we can also say that the drift velocity directly proportional to the electric field. Okay, and with this we got the relation between the drift velocity and relaxation time. It was simple derivation. Okay, and if you have any doubt you can ask me and comment in comment. Okay, and now let us continue the topic, and next topic is I am going to derive the relation between the drift velocity and current density and current. For that, let us see. I am going to rub the board. Okay, now I am going to start the next topic. This is very important for the exam. Many times came in the CBSE. Right? This is very important question. Right? In the third chapter. Now relation between the drift velocity and current. Relation between the drift velocity and current. Relation between drift velocity relaxation time completed. Now the relation between the drift velocity and current I am going to derive, or I am going to derive the resistivity formula. Okay, expression for resistivity of the wire in terms of number density and relaxation time. Okay, that I am going to derive. And for that, let us consider here this is a conductor. This conductor has the length L. L is the length of the conductor, And for this conductor, one side I am connecting to the positive terminal of battery and other side I am connecting to the negative terminal of battery. At that moment, electric field is generated from positive to negative for the conductor, positive to negative, this side. E is the electric field intensity. And here, due to the electric field, electrons goes from negative to positive, that is opposite to the direction of electric field. Electrons moves opposite to the direction of electric field, right? That is, drift velocity is Vd. Vd is the drift velocity, and the potential difference across the wire, because we are connecting some battery across this, that's where some potential difference is there. V is considered as the potential difference across the wire. And now I is the current through the wire and J is the current density. I am going to derive the relation between the drift velocity and current. It was very easy. Let us start. Okay. Now, first I am going to write one thing, that distance traveled by the conductor, by the electron, distance traveled by the electron through the conductor, right? How much distance electron traveled through the conductor? Electron traveled from here to here. Here we have the formula for distance. Distance is equal to average speed into time, right? Distance is equal to speed into time. The distance traveled by the electron is from here to here, that is L. Average speed is called as drift velocity, right? For the electron, V suffix D. The time traveled from here to here we can consider as T, Vd into T. This is equation 1. Okay. If N is the number density, if N is the number density of conductor, if N is the number density of conductor, what is number density? Number density means number of electrons per unit volume, number of electrons per unit volume, number of electrons per unit volume is called as number density of electron. How many electrons are there in the unit volume of the conductor? That is called as number density. Number of electrons per unit volume is called as number density of electron. Okay, is called as number density. Now let us see, in this case, N is the number density means, then how many total electrons are present in this wire? How many total electrons are present in the wire? For example, if capital N is the total number of electrons in the wire, capital N is the total number of electrons. The total number of electrons in the wire, the total number of electrons in wire, right? What you will get? The total number of electrons in wire I want, that is, we can consider as N. Here we have the formula for the number density, right? What is the formula for the number density? Number density is equal to number of electrons by volume, right? Number of electrons by volume. This is volume. Number of electrons by volume. Number of electrons by volume of wire, right? This is the formula. Number density is number of electrons by volume. And I want the number of electrons. Number density is what? Small n is the number density. If small n is the number density of conductor, number density means number of electrons per unit volume. Capital N by V. Total number of electrons. I want the total number of electrons. What you will get? From this, total number of electrons equal to number density into volume of conductor, right? Volume of conductor. Now, capital N is equal, number density is small n. What is the volume of conductor? Volume is equal to, this is just like a cylinder, right? Its area of cross section we will take as capital A. Its area of cross section is capital A. Its area of cross section is capital A means cylinder area. Area of cross section into length, right? AL we write. Okay, volume is area into length. But here n is equal, we write as small n into A into L we write from equation 1. VDT, VDT. Remember that V is suffix D, not V into D. V suffix D means drift velocity. This is from equation 1. Here we got number of electrons in the conductor. How much current flows in the conductor, right? Current in conductor. How much current flows in the conductor? How to find out the current? You know already very well. Current formula is what? Charge by time. But how much charge flows? If capital N electrons flows, then the charge is Ne by time. If small n electrons flows, small Ne. Capital N electrons flows means capital Ne. 1 electron flows means 1e. 2 electrons flows means 2e. N electrons flows means Ne is the charge. Now we substitute the n value at here from the equation 2. Then we will get the current formula is small n, capital N formula we are writing it here. NAVDT into E by T. Is it right? Okay, capital N formula we are writing. This from equation 2. Now, this T will cancel. Then what you will get the current formula, right? NAVDE. We write NEAVD. This is the current formula. NEAVD, and this is equation 3. And from this you can also write the drift velocity formula. Drift velocity formula, what you will get? Current by, you take this to left side. Okay, NEA, right? NEA. This is equation 4. Actually, what we want? Relation between the drift velocity and current. We got it here, current and drift velocity. And the next, I want the current density formula from this, right? What is the current density? Current density is current by area, right? Current is what? NEAVD by A, right? This will cancel. Then what you will get the current density? Yes, the current density we will get is NEVD, right? This is the formula for current density. Current density, equation 5. But we know VD formula in terms of electric field. I am also going to derive the formula for what? I am also going to derive the formula for resistivity, right? And for that, what we have to do it here? Now, continuation I will do. Okay? The continuation is that I am going to rub this. Take the screenshot and note it where you want. Okay, look at here. I am going to do the continuation. What happening at here? The J equal to NEVD we got. Then J is equal to NE into VD formula we know in terms of electric field, right? VD magnitude I am going to write E by M into tau, right? You know already we derived the relation between the drift velocity and relaxation time. That formula is EE by M into tau. Minus will be there, but we are writing only magnitude at here, okay? In NEA VD formula we are writing it here, that we know already. Now I am going to write like this: N E square N into small e square tau by M into E. Okay, and this is equation 6. But we know relation between J, sigma and E. Can you tell? J is equal to sigma E. This is equation 7. Compare equation 6 and 7, right? When you compare equation 6 and equation 7, what you will get? Can you tell? Left sides are equal, then the right sides also equal. Or otherwise J, J and E, E. Right, then we write sigma is equal to. Or otherwise we write like this. Okay, when you compare the two, we will get the sigma formula as sigma is equal to what you will get? N E square tau by M. This is the what? Sigma means what? Sigma means what? Can you tell? Sigma is what? Conductivity, right? Sigma is conductivity of wire, right? And I want the resistivity of the wire, right? I want to derive the relation between the resistivity. Okay, tell me how to find out the resistivity. Resistivity of wire. Resistivity is equal to 1 by conductivity. We know already, right? Resistivity is equal to 1 by conductivity. Then 1 by conductivity means it will be reverse, right? 1 by N E square tau by M. Then resistivity final formula what you will get? M by N E square tau. This is the relation between the resistivity. This is equation 8 and this is equation 9. In this, tell me what are the terms we have it here. Rho is the resistivity. M is what it here? Mass of electron. Mass of electron. N is what? Number density. We know already. What is number density? Number of electrons per unit volume. And what is tau? Relaxation time. Relaxation time. What is E? Electron charge. Do you know what is the value of electron charge? 1.6 into 10 to the power of minus 19. Okay. And this is about resistivity. And now let us discuss one problem based on this. Take the screenshot. I am going to rub the everything, and after that I will start the one problem. Look at here, this is our question. What they are asking in this question, what they gave in our question. Estimate the average drift velocity of conduction electron in a copper wire of cross-sectional area 1.0 into 10 to the power of minus 7 meter square. The area of cross-section they gave us 1.0 into 10 to the power of minus 7 meter square. Okay. And one more thing they gave, this is the number density, right? Density of conduction electrons. It is denoted with small n, that is 9 into 10 to the power of 28 per meter cube. This many electrons, 9 into the power of 8 electrons are there per meter cube. And area of cross current also they give. The current through the wire is 1.5 amperes. Look at here. Estimate the average drift velocity of conduction electron in a copper wire of cross-sectional area 1.0 into 10 to the power of minus 7 carries a current of 1.5 amperes. Assume the density of conduction electron to be this much. That means in copper wire, cross-section area is the give. This is a copper wire, right? Copper wire. Its area of cross-section they give. Right? In this, how much current flows, that they give, current I they give. And also they give their number density. Number density means number of electrons per unit volume. What they are asking to find? Average electron of electron, drift velocity. What is the formula for the drift velocity? We know current formula in terms of drift velocity, right? We know relation between the current and drift velocity, NEAVD. From this drift velocity formula, directly also we can write I by NEA. You know electron charge. Electron charge is what? 1 point. Electron charge formula is what? Electron charge value is what? 1.6 into the power of minus 19 coulomb. What we are going to find out? Drift velocity we are going to find out. Right? And substitute all the values in this. VD is equal to I by NAE. I value, N value, A value, E value. You can substitute. You will get the answer. Right? I value is how much it here? 1.5. By N value is how much? 9 into 10 to the power of 28. E value is how much? 1.6 into the power of minus 19. A value how much? 1.0 into 10 to the power of minus 7 meter square. Now you can simplify. You will get the drift velocity. Velocity unit is what? Right? Velocity answer you will get something and meter per second. Now you can calculate this and answer you can write in comment. Then I will expect answer from you. You can simplify and write the answer. Okay? Thank you for watching my lectures. If you will not subscribe till now, you can subscribe and share to your friends. Comment on my lecture. Thank you for watching my lectures.